So we just finished looking at the square root of a complex number. Now we're going to look at the two quadratics. So for the first one over here, we have z squared minus z plus 4 plus 2i, which equals to 0. Right, so straight away we can just use the quadratic formula to solve this question. So obviously we can go z then equals 2 minus b plus minus square root of 4ac all upon 2a. So minus b would be minus 1. So minus 1 minus cancel up, so we get 1 plus minus square root of, so we get square root of 1 squared, so b squared is negative 1 all squared, so 1 minus 4, a is 1 times c, so 4 times this, so we get 4 plus 2i all upon 2a. All upon 2a is just equal to 1. So that's what this gives us. So that's the first step. This part right here is very similar to what we just did, was the square root. So these two can be left alone together, the 1 and the 2 right now. So this is the main problem of this whole question. So let's just try and solve this right now. So we've got square root of, we can do the same process. So z squared equals to that, because we let that equal to z. 1 minus 16 minus 8i. So z squared equals to 1 minus 16 is minus 15 minus 8i. Again, we've got z squared equals 2 minus 15. So we do the same thing again. So we've got x plus iy all squared equals to minus 15 minus 8i. Expand, x squared minus y squared equals to negative 15. 2xy equals to negative 8. Another way you can solve this is by taking the modulus of the number. So we can just go 15, or basically Pythagoras, 15 squared plus 8 squared square root. Just take the modulus of that and we get 15 squared plus 8 squared, 289, square root of 289 is 17. So that then equals to 17. So this can be a lot easier when we come to solve these sorts of questions. So we get x squared minus y squared equals to minus 15. X squared plus y squared equals to 17. So we've just taken the modulus. Now what we can do is we can just add these together. 2x squared equals to y squared minus y squared and plus y squared cancel. Minus 15 plus 17 equals to 2. 2 cancel out. X squared equals to 1. X equals to plus minus 1. So if x equals to plus minus 1, we can sub that into here. So when x equals to 1, 2y. So when x equals to 1, so we can just come back. So this part we can just come to it over here. So when x equals to 1, we get 2y equals to negative 8, y equals to negative 4. When x equals to negative 1, we get y equal to 4. So basically this then gives us x equals to plus minus 1, y equals to minus plus, sorry, my bad, y equals to minus plus 4. Because x is negative 1, we go negative 2, minus 2y is negative 8, negative cancel. Yeah, x equals to 4. There you go. So now we can bring this back to this scenario here. So when x equals to 1, y equals to 4, negative 4. So we can come back over here, so we can rewrite this as in the complex form. We can go z then equals 2. We got 1 minus 4i, or minus 1 plus 4i. These are your two. These are the solutions for this value over here. So now we can rewrite this as, sorry, this is not z. But these are the solutions for this value here. So now we can, so let me rub this out. Rewrite this. So we can rub all of this out. We've got the answer. Make it easier. So this then gives us, so from here we can go equals to 1 plus minus 1 plus minus 1 minus 4i all upon 2 is your final answer. So we go plus minus minus plus. So plus minus minus plus. That's your answer right there. So 1 plus minus brackets plus minus 1 minus plus 4i all upon 2. So we can expand that. So we can go 1 plus 1 minus 4i all upon 2, or 1 minus 1 plus 4i all upon 2. So the final answer is 1 upon 2, or 2 upon 2 minus 4 upon 2i, or 2 upon 2 plus 4 upon 2i. So that's your final answer for this quadratic right here. So let's get on to the next one. Alright, for this next example, it's a little bit different. We've got a imaginary part in the coefficient, leading coefficient. So let's see. The process will be the same. We use the quadratic formula. So let's just start. So we got z equals to, so we'll rewrite the question at the top. So we have I z squared brackets minus 2i z plus 10 equals to 0. So we've got that. Now we can just rewrite. So we've got z equals to minus b. So minus all of this then becomes 2 plus 2i plus minus square root of that all squared. So we go minus 2 minus 2i all squared all upon, b squared minus 4 times a, which is I, so minus 4i multiplied by c, which is 10. So minus 4i multiplied by 10 would be negative 40i. So minus 40i all upon, this is the tricky part, 2 times a. So a in this case is going to be I. So we have 2i. Now what we do, we try and expand this bracket right here. So we'll just quickly expand it over here. So we go minus 2i brackets minus 2 minus 2i. Minus 2 becomes 4. Minus 2 multiplied with minus 2i becomes 4i plus 4i. Same thing, plus 4i plus 4i squared. I squared negative 1, so this then becomes minus 4. Minus 4. 4 and 4 cancel. This then gives me 8i. So that then gives me, that value gives me 8i. So let me quickly rub this out. Have some space later on. So we rewrite this as 8i minus 40i is negative 32i. So we can just rewrite that over there. So we have z equals to 2 plus 2i plus minus square root of negative 32i all upon 2i. All upon 2i. Now what we do is take this, do that same square root of a quadratic, square root of a complex number. Same situation we can go, but we can make it a bit quicker. We can go, so obviously z squared equals to minus 32i. We know the expansion of that. Let z equal to x plus iy. So I'm going to let it equal to x plus y. We can just expand that. So we go x squared minus y squared plus 2xy equals to 0 minus 32i. The only reason I wrote the 0 is because it's easier for me to then separate these into their respective groups. So for example, x squared minus y squared is real, and then 0 in this case is real. So we can just redo that. So we go x squared minus y squared equals to 0. Take the modulus of this. We can go x squared plus y squared. We can just do Pythagoras of that. So 32 squared square root, which just gives me 32. Pretty simple. Same thing. Now we go x squared plus x squared. 2x squared equals to 0 plus 32 is 32. X squared is 32 upon 2 is 16. X therefore then equals to plus minus 4. So if x equals plus minus 4, y then equals to, we sub this back into this part here, so we go 2xy equals to negative 32. Y equals to, sorry my bad, rewrite that. So y then equals to negative 16 upon x. So y then equals to minus plus 4. That's what we get, right? So y equals to minus plus 4. Bring that back to this situation. So I'll rewrite all of this over here. So I'll bring that. So we've got all of this. I'll bring it over here. Sorry, it gets a bit messy. But, so this, rewrite this over here. So we have z equals to 2 plus 2i plus, we're going to take the positive case of x and negative case of y, plus 4 minus 4i all upon 2i. And that. So we'll take the positive case first, we'll solve the positive case and then we'll solve the negative after that. So 2 plus 4 is 6. So z then equals to 6. 2 minus 4 is negative 2i all upon 2i. What can you do next? Multiply both sides by I. Cancel out. So multiply top and bottom by I. Cancels the bottom and top. So times by I upon I. This then becomes z then becomes 6i minus 2i squared. I squared negative 1 plus 2. Plus 2 all upon, the bottom becomes 2 multiplied by I squared. So negative 1. My negative 2. So z then equals 2. So we have 2 upon 2. Negative 2 is negative 1. 6 upon negative 2 plus, negative 1 minus 3i. There's your first solution to this. Now we do the same for the negative case. So we go that, so that then becomes negative 4 and that becomes positive 4. So we have z equals to 2 plus 2i minus 4 plus 4i. So 2 minus 4 gives me negative 2 plus 6i multiplied by 2i. So multiply both sides by I. So we go same thing, I upon I. The top then becomes, go down all the way over here, minus 2i. And then this becomes minus 6 all upon negative 2. So this then gives me, minus cancels, that gives me 1. This final answer is 3 plus I. So these are your two final answers. We've got minus 1 minus 3i and 3 plus I.